Hello, yeah. In this video, I want to discuss how to perform multiple imputation and then fit GE models for longitudinal data with missing at random missing values using R. So in general, based on the theory, if you use a GE model and the missing data is missing complete at random, then with large sample size, assume your model is correctly specified. Your parameter estimates should be consistent. Okay, so in other words, GE tolerates missing complete at random data, but then it will be biased if there's missing at random data. Okay. And for missing at random data, if you want to use a GEE, there's a way to use weighted GEE to handle missing at random data, but that's limited to monotone dropout missing data, not the intermittent missing data. Okay. Multiple imputation is another way to handle missing data. It's a very general approach, but here we're just use multiple imputation together with GE model to handle missing at random data. Okay. And there are also examples showing how to use multiple imputation in combination with linear mixed models, which I think is necessary because based on theory, the mixed facts models, if you use maximum likelihood estimate, they should be consistent in large sample size if the data is missing at random. Okay. Okay, so let me show you. We need a couple of libraries. One is mice for multiple imputation based on chain equations. And then we have GEPAC, DPLYR, and TidyR. First, set random seed, create sample size 100, 5 data points, time points, and then generate the data. And there's a group variable, there's an age variable, and the score, which is a dependent variable. And this is what it looks like. And we introduce missing at random data. So basically, the probability of missing will be predictable by age. Okay. So now we introduce the missing data. So this is a look what it look like now. Though there's an NA in score. Okay. All right. To perform multiple imputation using the mice package, so the syntax is pretty simple. You can use mice of data, then m equal to 5. That's the default. As we know, in general, when you do multiple imputation, 5 imputation should be okay. Method equal to PMM. There are several options you can use, but if you use PMM, I believe it handles both categorical and continuous variables. Okay, and seed equal to 500. Okay, so you can do that, do the imputation, and it's really very quick because we only have very small amount of missing data in the score. Okay, and if you want to take a look of this object from mice, it's highly complicated. It's a list of let me see, list of 22. So it has 22 components in there. Okay, but the reason I picked I picked mice is because it has also a pooled function that you can combine the models on these multiple imputed data sets. Okay, so let's reshape the imputed data to the long format for GE analysis because that's what's required by the GLM function from the GEPAC. Okay, so to fit GE models on the imputed data sets, You can use the width, then imputed data set. The imputed data set has 5 data sets in there, and then you say GLM, you get the formula, ID, the family, and the correlation structure. Okay, and then after you fit these 5 GE models, you need to put results together. Uh, the reason I picked the mice is it has very convenient pull function here. There are other multiple interpretation packages, which I don't think they are as convenient as mice when it comes down to pulling models. Okay, so let's pull the model. So you use a pull or fit GE, and then now you get one pulled result, and it look like that. So basically, it gives you the coefficient estimates and the betas and standard error, statistic, DF, and the p-value. Okay, so in this case, it looks like the group and the age are highly significant. Okay, even though there are missing data in the score. Okay. So this is maybe a quick way to handle missing at random data in a longitudinal data set when you use GEE models. Okay. All right. Of course, multiple interpretation, it's a big topic by itself. And the R-packaged mice is very rich. There's so many informations in there. I strongly encourage you to read its documentation. The pooled analysis after the multiplication can be challenging, and people have developed and are probably still developing like how to pull results from different analysis, such as like partial least squares, things like that. Okay, and some people did multiple imputation in combination with linear mixed models, and you can use the pull function to pull inferences on the fixed effects, but so far pulling estimates on the random effects is still an open question. Okay. All right. Thanks for watching.